For us to find the area of this shaded rectangle, one thing you could do would be to use the triangle, apply Pythagoras' theorem to find the side lengths and multiply them together. You're going to get square roots. It's not going to be particularly nice. Actually, I might go through that in a minute. But the better way to do it is just to find the area of the whole square and then subtract the non-shaded parts. So the whole square is an 8 by 8 grid. Therefore, the area is going to be 8 squared, 8 times 8, which is 64. Okay, I'm going to look at the bottom left and top right. Imagine moving this up here. I'd actually create a 3 by 3 square. So if I subtract 3 squared, then I'll remove these two from the grid. And then I can do exactly the same with, imagine moving this up here. And now I've got a 5 by 5 squared. So if I minus 5 squared, that will remove this one and this one. And I'll be left with 64 minus 9 minus 25. I can add the 9 and 25 together. That will give 34. Becomes 64 minus 34. Or you could subtract them one at a time. It's up to you. Which gives a final answer of 30. So C. Let's just take a look at that Pythagoras idea just as an alternative. Okay, at the bottom, I've got a 3 by 3 triangle. So this side would be 3 squared plus 3 squared square rooted, which is 9 plus 9 square rooted. It's the square root of 18. And then if I look at the other side, it's 5 by 5. So then I do 5 squared plus 5 squared square rooted, which becomes, so that's this side here, that becomes root 50. And then I could do root 18 times root 50. In fact, you can bring the two together. So it's 18 times 50. Quick way to do this is to have the 18 and double the 50, because then that doesn't change the multiplication. So 9 times 100. So it's the square root of 900, which is then 30. So it works out okay. I think it's a bit more complicated, but it's an alternative method.